Okay, welcome to the January 2023 4MA1 1H walkthrough on the Edexcel IGCSE. Okay, question number 1 is a group frequency table. To find the mean of a group frequency table, we shall multiply the mid-interval values, that's halfway between the lower and the upper value for each interval, by its frequency, divided by the sum of the frequencies, or just read the 80 at the top to get 27 for the first one. Question 2, algebraic equation. We expand out the left-hand side to begin with. We could bring the x's onto the left and the constants onto the right. I'm not going to do that. I'm going to do it the other way around to keep everything positive, and we get x equals a quarter there. Fairly straightforward. Apologies for my poor effort at number 3. This would not score marks. However, yours should look a little bit like this, but you'll have used a pair of compasses to draw the arc lengths, putting the compass point at points A and B to draw arcs above and below the line from both sides, and then join those up using a ruler to look something far superior to mine. Question 4, we've got ourselves a pentagon. So if we take the number of sides of a pentagon and subtract 2, multiply that one by 180, we'll get the 540 degrees, which is the sum of the interior angles of a pentagon. If we sum the 4 angles we do know and subtract those from 540, we'll get our missing angle x, which is 129 degrees. Question number 5 is a ratios question. It tells us that the green sweets to orange sweets is 2 to 3, and the orange sweets to the yellow sweets is 1 to 5. So what I'm going to do is I'm going to adjust the second ratio. So rather than 1 to 5, I'm going to call that 3 to 15, and that gives us a ratio between the 3 coloured sweets, so 2 to 3 to 15. We'll split the 280 by the sum of those to get the value of one part, so 280 divided by the 20, so 14 sweets is one part. 2 parts are green, so we'll double the 14 to get 28 green sweets in the box. Question number 6. We've got 186,000, and if we add 14 lots of 1,160, those are the monthly payments along with the deposit, it gives a total of 34,240. Subtract that from the 32,000, which is the amount Shane paid, and work that out as a percentage. So divided by 32,000, times it by 100, and you can see that comes out as 7%. Okay, for B, it's a reverse percentages question. So if we take the original price, or the old price, times it by 0.85, that represents a 15% decrease. We get the new price, it's 39,865. So if we divide 39,865 by 0.85, we'll get the old price, which is 46,900. Question 7 is the probability question. We know that for a discrete random variable, the probabilities are going to sum to 1. So I'll add together each of the probabilities, and we can solve the equation to find x. I'll bring the 0.24 and 0.4 onto the right-hand side, divide by 4, we get x equals 0.09. We want to work out the probability of the mystery books, so I'll times that by 3 to get 0.27. By dividing 48 by 0.24, it works out the total number of books. In this case, it's 200, and so 200 times by the probability 0.27 gives us 54 mystery books in there. Question number 8. Starting with a bit of SOHCAHTOA, cos of 50 will be the adjacent over the hypotenuse, that's 18 over AB. multiply both sides by AB, divide by cos 50, we'll get AB is 18 over cos 50, which comes out as a tiny bit over 28. So the perimeter of the circle is going to be that length AB, the 28, plus, and then it's half a circle, so half of 2 pi times the radius. The radius is half of AB. You could just simplify that before doing the calculation if you wish. There's a few ways you could acceptably simplify. Anyway, it comes out as 71.99, which rounds to 72 centimetres to 2 sig figs. Question 9 is a standard form. Okay, it was an ordinary number 0.000625 and 2.5 times 10 to the 7 for the two answers there. Question 10, simple factorising y minus 8, y plus 6. For question B, that's x is less than or equal to 3. And for C, I bring the w's onto the right-hand side of the inequality and the numerical components onto the left. Divide both sides by 5. I don't need to think about changing the signs because 5 is positive, and we'll get w is less than negative 8/5, or the other way around, that's fine. Question 11, it gives us the equations of the line, so actually I'm just going to carry out a point test. We know that the point 1, 1 is within the region, so I'm going to take each of the 3 equations and substitute 1 into them. So the first one was 2x plus y equals 6. Well, when x and y is 1 and they're both 1, we get 2 plus 1 and 6. And then I'm going to draw in the inequality because 6 is greater than 2 plus 1. And rewrite the 3 equations with those inequalities included. I'm going to allow the or equal to because these are thick lines. Okay, question number 12, to find the value of m. Well, we need to add the powers, so 1/2 plus 2/5. It's the same as 5/10 plus 4/10, which is 9/10. 0.9 is perfectly acceptable. For B, we're carrying out a division, so when we're dividing numbers with the same base, we subtract the powers. -10 subtract -4 is -6. Question 13, expanding 2x minus 5 squared. 2x times 2x is 4x squared. We're going to get 2 minus 10x's to make minus 20x, and minus 5 times minus 5 is plus 25. And then multiply each part of that by 3x. And we get a fully expanded expression. Plug in 0.5, you get 12. Plug in 2, you get 4.5. And then we just have a series of points to plot one at a time. Make sure you're careful with plotting the points. They need to be within half a mini square of the correct location. So do be as accurate as you can. And when you draw your line, again, try to make yours more accurate than mine is. Not a bad effort by my low standards. Alright, question 15, the probability question. Well, there are 2 numbers and 7 letters, so that's a 2/9 chance of it being a number and a 7/9 chance of it being a letter. Once the first card is withdrawn, the denominator will change. We'll get 1/8, 7/8, 2/8, 6/8. The part B. So we need them both to be numbers. So there's a 2/9 chance of the first one, a 1/8 chance being the second one. We need both of those to be true. So we'll multiply them together. Gives us 2 over 72. You can simplify if you want, you don't have to. For C, so we could have a number and a letter, or a letter and a number. So 2/9 times 7/8 and 7/9 times 2/8. We don't mind which one, so it's one or the other. So the or suggests that we should be adding these to give us 28 over 72, which simplifies, if you wish, to 7/18. Question 16. First thing I'm going to do is find that angle ABC using the sine rule. So sine of ABC divided by the length that is opposite it, in this case 24, that will be equal to sine of 64 divided by the length that is opposite that one, which is 31. If we multiply both sides by 24 and then carry out inverse sine of that fraction, we'll be able to calculate the angle ABC. This comes out as 44.09 degrees. When I do the next calculation, I keep that number on my calculator and use the answer button. I don't want to round part way through a question. To work out the angle ACB, we'll subtract the two angles we have in the triangle from 180 degrees, comes out to 71.9 degrees. DCE is vertically opposite, that's 71.9, so it's also 71.9, and it gives us enough information to carry out a cosine rule to find DE. I can do that in one big step. Square root of b squared plus c squared minus 2bc cos of the angle between them. DE comes out as 20.7 centimeters. Question 17 is a proportionality question where the constant we're given is given as just a letter to represent the constant. So we'll start off with a proportional statement, turn it into an equation, y equals k over root x, substitute y to be c to the 4 and x to be c squared. Square root of c squared is c. That's fine because c is a positive constant. Multiply both sides by c, we get k equals c to the 5, and so my equation is y equals c to the 5 over the square root of k. Question 18. If you spot that k over x is just a self-inverse function, that's absolutely fine. You can do a little rearrangement if you want to, I've just shown there, but the inverse function is also k over x. For bi, substituting negative 2 into g, we'll get subtract 3 lots of negative 2 to the power 4, which is negative 46. Finding the composite function h of g of x, so we're going to embed g of x into h of x. So looking at h of x, wherever there's an x, I'm going to write 2 minus 3x to the 4 instead, in the numerator and the denominator. The denominator simplifies quite nicely, the 2's cancel, and then you're subtracting negative 3x to the 4, which just leaves us with 3x to the 4. I haven't done anything with the top because I can cancel the 3's, the common factor of 3 at the top and the bottom, leaving me with 2 minus 3x to the 4 over x to the 4, which is my simplified composite function. Question 19, upper and lower bounds. Whenever I get an upper and lower bounds question, the first thing I'll do is I will list the upper bound and the lower bound of each one of the variables that they've given me to the required degree of accuracy. So we get the upper bound and the lower bound for v, the upper bound and the lower bound for u, and then the upper bound and the lower bound for t. Alright, that is always worth doing because you'll get marks for doing so. Then we need to calculate an upper bound and a lower bound for a. So for the upper bound of A, I want to take the upper bound for V, because I want that to be as big as it can be. I want to take the lower bound for U, because I want that to be as small as it can be. And I want to take the lower bound of T, because I want that to be as small as it can be, because we're dividing by it. And that gives me the largest value of A we can get out from using those as 4.7479, etc. For the lower bound, we're actually going to choose the opposites to all of those. We want V to be as small as possible, U to be as big as possible, and T to be as big as possible. That will give us the lowest outcome. And it comes out as 4.69298. Then looking at rounding those, well, if you rounded it to 2 decimal places, you'd get different answers. So we'll round it to 1 decimal place, 4.7, and that's our value of A. Question 20 is the calculus question. Leads us in with the volume of a cylinder, pi r squared h. We know that r is x and h is 800 over pi x minus x. I'm going to expand out my expression for the volume, cancel the pi's, cancel an x, we get v equals 800x minus pi x cubed. If we differentiate that, remember we have to treat pi as a constant, so the differential comes out as 800 minus 3 pi x squared. Equate that to 0 because we're finding a stationary point. The maximum is of course a stationary point, and solve the equation. Bring the 3 pi x squared onto the left, divide by 3 pi and square root it. So x is the square root of 800 over 3 pi, or 9.21, etc. if you prefer. That's our optimal value of x, so I shall now substitute that into my expression for the volume. I'm using the simpler one. 800 times my new value of x, subtract pi times my new value of x cubed, comes out as 4,914 centimeters cubed. You could do that question on a GDC by plotting it as a graph and gsolve max, more efficient. It actually doesn't say we have to show clear algebraic working, so that would be fine. Question 21, we've got 14 centimeters per second over 180 seconds, which is 3 minutes. So 14 lots of 180 times by the area of the segment there. To find the area of the segment, we find the area of the sector and subtract the area of the triangle above it. I'm just using standard formula here. Times them all together, 8,870 is the correct answer. So it's theta 360th pi r squared for the sector and half AB sine C for the triangle. Question 22, the arithmetic series question. It's given our first term and our nth term in terms of another variable t, but I'm just going to treat them as objects. They are just numbers after all. So our first value a for this will be 2t plus 1. We know that the nth term of an arithmetic is a plus n minus 1 lots of d. You don't get given that in the formula booklet, so you do need to know that one. And then I'm going to plug a for 2t plus 1 in, and it tells us that that will be equal to 14t minus 5. Bring the 2t plus 1 onto the right, expand, and bring the minus 3 onto the right. Divide by 3, we get an expression for n, which is 4t minus 1. There are a few ways of doing that and ending up there, which would be absolutely fine. Then subbing it into the formula for the sum of n terms, get n over 2, lots of 2a plus n minus 1d. You do get given this formula. N is 4t minus 1, a is 2t plus 1. And so we can now expand and simplify. The stuff inside the bracket simplifies to 16t minus 4. I can factorise a 4 out of that and cancel the 4 and the 2 in the denominator to give me 2 lots of, and then it will be a 4t minus 1 from the original n, and then the inside of the brackets, now it's been factorised, is also 4t minus 1, and that all collects together nicely to give me 2 lots of 4t minus 1 squared. And then if you want to therefore label your p, q and r as 2, 4 and 2, that's absolutely fine. Question 23 is the kite question. Apologies for my drawing on this one. I don't know how closely that resembles a kite. Not particularly good. Anyway, we'll label it A, B, C and D. B we know is the point K1, D is the point 8, 7. So it tells us that L is parallel to the line 5y minus 3x equals 6, so we can use that to work out the gradient of L. A quick rearrangement into y equals mx plus c form, we can see the gradient is 3/5, and that will also be the gradient of L. So we can construct the equation going through the point D with a gradient of 3/5. This line will also go through B, but I'm not worrying about that just yet. Y equals 3/5 x plus c passes through the point 8, 7, so y is 7 when x is 8. I can use that to work out what c is. Subtract 3/5 of 8 from 7 and we get c to be 11/5. So the equation of the line passing through BD is y equals 3/5 x plus 11/5. Now because that passes through the point B, which is coordinates K1, I can substitute y to be 1 and x to be k into that equation and solve to find k. I take a shortcut of multiplying everything by 5. Well, not necessarily a shortcut, a simplification, gets rid of the fractions. And we get k to be -2. And that gives us the coordinates of B. We now know that B is -2, 1. We'll find the midpoint of BD. That's going to be useful because we know that the midpoint of BD will be on the line that travels through AC, which is the one that we're searching for. Using the formula for a midpoint, x1 plus x2 over 2, y1 plus y2 over 2, we get that midpoint of BD to be the point 3, 4. The gradient of AC is perpendicular to the gradient of BD. BD had a gradient 3/5, so the gradient of AC is a negative reciprocal, that's -5/3. Therefore, the equation of the line that passes through AC is y equals -5/3 of x plus c. We know it passes through the midpoint, so we can use the coordinates 3, 4 to work out what the c must be. Substitute y to be 4, x to be 3 into the equation. We can deduce that c is equal to 9, so the equation is going to be y equals -5/3 x plus 9. If we times everything by 3, we get 3y minus 5x. 3y is equal to -5x plus 27. Bring the 5x onto the left-hand side. We get the correct answer, 5x plus 3y equals 27. Question 24 is the vectors question. I'm going to start off by calculating the vector from O to E. The path to get from O to E, I'm going to go from O to A, and then from A to D, and then from D to E. Add the 3 together and we'll get O to E. O to A is very straightforwardly 2A. A to D we know is 3 lots of A to B, because the ratio of A to B to B to D is 1 to 2. So we can get 3 lots of A to B. A to B is -2A plus 2B. And then lastly, to get from D to E, that's a vector that's given to us, is 7a plus 3b. If we expand and simplify, we can get O to E to be 3a plus 9b. Right, now this is the trickier bit. We're going to find O to C two ways. If we do it in two separate ways, we can compare the coefficients of little a and little b, and that will allow us to find the exact vector O to C if we wanted, although we don't actually need it at the very end. The simplest way from going from O to C is to say it's a proportion of the vector from O to E, so we call that proportion lambda, so lambda lots of 3a plus 9b. Or if you prefer 3 lambda lots of A plus 9 lambda lots of B. The second way of going from O to C is to go from O to A and then from A to C. And that's going to be 2A to get from O to A plus mu lots of, and that vector there is A to B minus 2A plus 2B. If I expand that out and factorize, we'll get 2 minus 2 mu lots of A plus and then 2 mu lots of B. Now we know those two vectors for OC are the same, so we can equate the coefficients. We'll have 3 lambdas is equal to 2 minus 2 mu. That's for the little a's, and then for the little b's we'll get 9 lambda is 2 mu. We could divide both sides by 2 to get mu in terms of lambda. We actually didn't need to do that. Now there is a mistake here in my working. It should say 3 lambda equals 2 minus 9 lambda, replacing the 2 mu for 9 lambda. Adding 9 lambda to both sides, we'll get 12 lambda equals 2. Divide both sides by 12, we'll get lambda equals 1/6. Well, lambda is a proportion of O to C from O to E, and so the ratio between O to C and C to E will be 1 to 5. Well done if you got that one.